Africa is in the process of slowly tearing apart. A massive crack spanning several kilometers has suddenly emerged in southwestern Kenya. This ever-expanding tear led to a section of the Nairobi-Narok highway collapsing. Initially, the formation of this crack was attributed to tectonic activity along the East African Rift. However, geologists currently believe it's more likely an erosional gully. So what's really behind this division of Africa? What's causing the land to split open? And what are the implications for both the people of Africa and the world at large? In today's video, we explore the phenomenon of Africa gradually dividing into two continents, a development that many people might not be aware of. Our planet Earth is in a constant state of transformation. While some changes occur so gradually that they're imperceptible to us, others can be quite dramatic, sparking discussions about the potential splitting of the African continent. The Earth's lithosphere, which includes the crust and the upper mantle, is divided into various tectonic plates. These plates are not stationary but move in relation to one another at different speeds. They essentially glide across a viscous layer known as the asthenosphere. The exact mechanisms responsible for this movement are still a subject of debate, but they likely involved convection currents within the asthenosphere and the forces generated at plate boundaries. These forces don't merely relocate the plates, they can also cause plates to rupture, leading to the formation of a rift and the possible creation of new plate boundaries. One such active example of this phenomenon is the East African Rift System. Now, have you ever noticed that the eastern coast of South America seems to fit perfectly with the western coast of Africa when you look at the globe? This observation is not coincidental. These land masses were once joined together. According to NASA's Earth Observatory, the Somalian Plate, also known as the Somali Plate, in the east is moving away to the east of the larger, older part of the continent, referred to as the Nubian Plate, sometimes called the African Plate. Interestingly, both the Somalian and the Nubian plates are also drifting apart from the Arabian Plate in the north. These plates converge in Ethiopia's Afar region, forming a Y-shaped rift system as described by the Geological Society of London. The process of the Somalian Plate breaking away from the Nubian Plate is referred to as the East African Rift. This geological phenomenon is a system of valleys that extends over approximately 2,175 miles, spanning from the Red Sea to Mozambique. If the Somalian tectonic plate were to eventually detach entirely from the larger Nubian Plate, it would result in the splitting of the world's second largest continent, a development of great interest to geologists and scientists. This kind of event has not been witnessed since the separation of South America and Africa into distinct continents hundreds of millions of years ago. However, it's essential to note that if this separation were to occur, it wouldn't be observable in our lifetimes. Such a process would take an estimated 5 to 10 million years to reach completion. A full separation of the Somalian Plate might not be the only possible outcome. It's conceivable that we could see most of the Somalian Plate separating from the rest of the continent, resulting in the formation of a new sea between the two landmasses. This newly created region would encompass countries like Somalia, Eritrea, Djibouti, and the eastern parts of Ethiopia, Kenya, Tanzania, and Mozambique. There's also the scenario to which only eastern Tanzania and Mozambique separate. In this case, landlocked countries like Ethiopia and Uganda would stand to benefit significantly. The emergence of a coastline due to the formation of a new ocean would offer substantial economic opportunities, such as enhanced trade and production. According to Ken McDonald, a marine geophysicist and professor emeritus at the University of California, Santa Barbara, the Gulf of Aden and the Red Sea would eventually inundate the Afar region and the East African Rift Valley, giving rise to a new ocean. This transformation would turn that part of East Africa into its distinct and relatively smaller continent. The visible evidence of the rift suggests that it's in progress, but it's not expanding rapidly at this moment. It's actually separating at a rate of about 1/4 of an inch every year. Now, you might be wondering how these rifts come about and why there's still debate among geologists and geophysicists regarding their formation. A prevailing model has gained prominence, proposing that an increase in heat flow from deep within the Earth is generating what's known as thermal bulges. These bulges are notably observed in central Kenya and the Afar region in north-central Ethiopia and are easily identified on topographic maps as elevated highlands. As these bulges develop, they exert pressure on the outer brittle crust, causing it to fracture along a series of normal faults. Most geologists and geophysicists attribute the formation of these bulges to heat generated by mantle plumes beneath the continent. A mantle plume is a region under the Earth's crust where magma is hotter than the surrounding magma. The heat from this hotter magma causes the overlying crust to melt and thin, leading to the expansion and fracturing of the bulges. This process can also result in extensive volcanic activity on the Earth's surface above the plume. Typically, the stretching of thermal bulges is often preceded by massive volcanic eruptions that spread across large areas. These eruptions are often visible at the edges of the rift. In geological terms, these eruptions are referred to as flood basalts. During such eruptions, the lava flows along the fractures in the bulges instead of erupting from individual volcanoes. The lava then spreads over the land like a flood. One striking feature of the ongoing African rift is the presence of a rift valley. A rift valley is a lowland region formed when two tectonic plates move apart or rift. These valleys are commonly found both on land and at the bottom of the ocean. In oceanic environments, they result from seafloor spreading. Unlike river valleys and glacial valleys, which are shaped by erosion, rift valleys are created by the movement of tectonic plates. Many rift valleys are associated with triple junctions. Triple junctions occur when three tectonic plates meet at angles of approximately 120 degrees. In such cases, two arms of the triple junction often separate to give rise to an entire ocean, while the third arm, sometimes referred to as a failed rift, can develop into a rift valley. An example of this process is the formation of the Atlantic Ocean. The Atlantic Ocean emerged from a triple junction that initially existed in what is now the Gulf of Guinea and the west coast of Africa. Two arms of the triple junction led to the creation of the ocean, while the Olukogan formed the rift valley known as the Benue Trough, running through what is currently southern Nigeria. Now, looking at the East African Rift, it encompasses two primary branches, the Western Rift and the Gregory Rift. The Western Rift, also known as the Albertine Rift or the Lake Albert Rift, encompasses the East African Great Lakes and is known for its extraordinary biodiversity. This region boasts an array of environments, from snow-capped mountains and savannas to highland forests and unique lakes. In contrast, the Gregory Rift, named after the geologist who initially charted it, extends from the Red Sea and the Arabian Sea to as far south as Mount Kilimanjaro. The Gregory Rift is characterized by the presence of the Afar Triple Junction, a highly significant geological phenomenon. At this triple junction, the Horn of Africa spans the Red Sea and the Gulf of Aden and the Arabian Sea. It's a point where the Arabian Plate, Nubian Plate, and Somali Plate are all moving apart from one another. A noteworthy observation is that the two arms of the Afar Triple Junction continue to widen through the process of seafloor spreading. One of these arms extends into the Red Sea, while the other extends into the Gulf of Aden. As these rifts persist, the small valleys formed by the Gregory Rift might eventually sink to the point where it's flooded by the waters of the Arabian Sea. If this occurs, the Horn of Africa will transform into a continental island, akin to regions like Madagascar or New Zealand. It's also worth noting that the East African Rift, even though it emerged from the same geological process, exhibits distinct characteristics in its western and Gregory branches. The Gregory Rift is marked by heightened volcanic activity, while the Western Rift features notably deeper basins, hosting large lakes and abundant sediments. One of these prominent lakes is Lake Tanganyika, ranking as the world's second deepest lake. Another is Lake Malawi, where geologists have observed basalt eruptions and active crevice formations. Scientists have increasingly turned their attention to the East African Rift system as a unique opportunity to study how ocean basins form on land. This presents an exciting prospect for researchers, as it allows them to directly investigate the mechanisms behind rift formation. Such a chance is rare globally because most rifts are either filled with sediments or submerged underwater. In contrast, the East African Rift system serves as a prime, real-time laboratory for studying an actively evolving rift system. As the East African Rift continues its journey to divide the African continent, the region has garnered increasing significance for various stakeholders, from geologists and ecologists to governments. All eyes are on the developments within the Rift Valley. Its importance extends to unraveling the complexities of the human evolution. The rift has yielded numerous hominid fossil discoveries and earned the name the cradle of humanity. With an array of paleoanthropological findings, scientists are actively exploring how the rift's evolution may have played a pivotal role in the development of our species. That's all for today. If you enjoyed this video, be sure to subscribe to our channel and enable notifications to stay informed about our future content. Thanks for tuning in.